Okay, hello. Now we're going to talk about the substitution method with two equations. We have two unknowns. One equation does contain fractions. The other equation does not. One equation that has the fractional coefficients, the 2/3 x minus 1/3, equals y. That y is already isolated, as you can see. So what happens is we're going to have to use that equivalent for y equation and substitute for y in the second equation. Hmm. Okay, now what you can see is I've replaced the y variable in the second equation with the equivalent part of the equation in the first one. So now we have one equation and one variable, and we can solve for x then. So we have 3 multiplied with the distribute over the quantity 2/3 x minus 1/3. We're going to reduce our fractions. 6/3 reduces to 2, and 3/3 reduces to 1. If you look at the left side of the equation now and the right side of the equation, they are the same expressions. Well, I mean, looking at it, it seems like they seem to be equal. They seem to already be true. But we'll just see what happens with x, okay? Oh, excuse me. I'm sorry about that. I didn't like how that sounded, what I wrote there. Okay, now the x term, as we had, dropped out of our solution. So we have -1 equals -1. Now this statement is true. It's impossible for that to become false. -1 will always and forever equals -1. Therefore, the two equations what we call consistent or dependent on each other. What that means is they share an infinite number of pairs, x and y pairs. The two will, if you saw my other vlogs on the graphing method with the consistent system, what happened was the two lines were on top of each other. So they shared the same x and y pairs. Therefore, this system will always be true